Senzations and come from the University of Bologna. Since we are quite behind the schedule, I will try to be as fast as possible and as painless as possible. And I will present you the topic, which I call it experimental evaluation of routing protocols for smart city and internet fixed application. The main reason I wanted to present this is because of the fact that it's perfectly in line with the topic of this school, and also I figured out that it fits very well with the presentation that Alex gave the first day. I'm sorry that he's here now. Anyway, what I wanted to say is that he mentioned several testbeds that can be used within this framework, and I would like to present this project, basically give an overview of some more testbeds that are available and some preliminary work that has been performed. So, during this presentation, I will describe you the UWIN project, the new Comstar project UWIN testbed that we used. Then I will dedicate the first part to the motivation, which was also described by Alex, the motivation for using testbeds for experimental characterization of the work. And the second part will be dedicated to describing some proposed solutions and aiming routing protocols, aiming at controlling traffic congestion in wireless networks. And if I have time, I will finish with a brief overview of one project that we did, the smart city applications. Okay, so to start. UWIN is the European Laboratory of Wireless Communications for the Future Internet, which has been established within the framework of the European project, Network of Excellence of Wireless Communications, new Comstar. UWIN is composed of 3 sites, research laboratories of CTTC in Barcelona, then Sofia Antipoli, Euracom Institute, and University of Bologna. The focus of University of Bologna facilities is Internet of Things and the future Internet. And as we can see here, more specifically, to be more precise, the laboratory puts on disposal more than 200 different nodes, distributed different platforms that can be used for testing new networking technologies, new protocols that can be used for different kinds of evaluation. And more specific, we have on disposal 3 testbeds. Well, the third one is still not available. The first one is flexible topology testbed FlexTop, which I will describe in more details later. Then the data sensing and processing testbed, which consists of 50 802.15.4 compliant nodes, which are fixed and equipped with temperature and luminosity sensors, as well as 50 mobile nodes, which are battery equipped, which can be used to test, for example, delay-tolerant routing protocols. The log test, once it will be on disposal, can be used for, it will consist of 50 ultra-wideband nodes, which can be used for testing localization algorithms. So, this is the description of FlexTop testbed. As you can see, nodes are distributed along the building, fixed positions, and the main advantages of this testbed that has been used in this work are that it is remotely accessible via which we already seen during the description of SmartSantander, via the over-the-air programming. And the other advantage, the main advantage of this testbed is that it is deterministic, it is a stable environment, since all experiments will be performed during the night. So we have like a stable environment and well-controlled environment which certifies results. This testbed consists of 108.2.15.4 compliant nodes. They are CC2530 based solutions. And we'll go back. We have coordinators. We can see only one here, but there are actually 2. And apart from these nodes, and we have sniffers which are used for monitoring purposes. So, why we started all of this? Deploying a new application is rather challenging tasks, and simulation is just one step toward the evaluation of practical usage of these systems. It has been shown in many works that simulations are not always so accurate, that they lack realism, and this is mainly due to the abstracted physical layer modeling. We experience these issues, and in order to deploy an application, we need a more precise and accurate tool. The most of the work in wireless sensor network is based on simulations, and we should try to push it toward the experimental evaluation. Okay, simulations, yes, it's true. They are very flexible. They are, let's say, cheap. They provide very easy data collection and analysis, and but as I already said, they are often accused of not providing real-world results. And this is why we need to go toward in order to perform a proper study and research, toward the experimental evaluation, and in order to do it, we need an efficient and reliable testbed. Okay, what did we do? This was the preliminary test. The first thing, okay, the very important thing to mention is that this has been done before the final deployment of UBIN testbed. So devices were not on the walls as it was supposed to be, but they were positioned on the ground. This caused many issues, connectivity issues we had with the devices. We need to cope with them. We had to basically match this connectivity and propagation environment in simulations and experiments. It took us quite a lot of effort. At the end, what we did, we observed four sources, 32 routers, and a coordinator. And they were positioned according to a fixed grid. And what was the protocol that we used? Okay, at the PHY and the MAC layer, we used standard data 2.15.4. At the network layer, we used ZigBee default AODV routing protocol. We wanted to, I know many times people ask me, okay, why AODV? It's terrible. Yes, it's terrible, but it's default, and we need to start from a reference point. We just deployed this testbed, and we want to see from basic things toward the more complicated things, how the things develop, how they behave. So these sources were transmitting data to the coordinator with different data generation rates, and they were not synchronized. And what we did, we separated the routing discovery phase from the data transmission phase, meaning that the source, once starting to transmit, willing to transmit data toward the coordinator, first basically initiates the path discovery. When it has path toward the destination, it starts transmitting data. We evaluated the results in terms of packet loss rate and total overhead generated in the network. We compared this with the simulations, which were done in NS2. Okay. This is the first result. We have quite an offset between these curves, as you can see. The packet loss rate, okay, the trend is in both cases okay, meaning that with the larger data generation rate, we have a larger packet loss rate, but we have this quite large offset between simulation and experiments. This is mainly due to the fact that in experiments, we had much larger overhead than in simulations. And we experienced the collision between the overhead, between control packets and our data packets. And this happens because in experiments, it was quite difficult to control this separation of phases, route discovery and data transmission phases, while in simulators, it was perfect, they were perfectly separated.
Why did you choose the NS2 simulator?
Because partners who do this with us work in NS2. We are switching to NS3. As I already explained, yes, these simulations were performed by CNRS Nibos Lab from France, and this is the total overhead generated in the network. And I already explained why we have this difference, but the trend is also interesting because we see that with larger data generation rates, overhead is decreasing. Why? In cases of lower data rates, the nodes have less difficulties in finding the path toward the destination. But in that case, let's say that routers are not occupied by retransmitting these data, so they can hear these control packets and they all rebroadcast them. And we have a flooding of the network basically with these packets. While in the case of large data rates, data generation rates, sources are those that have more difficulties in finding. So at this initial phase, they transmit more router requests, but at the end, we have that these routers who are supposed to retransmit those packets are already retransmitting data packets, and in that case, we have this lower overhead. The second part of the presentation will be dedicated to explaining some proposed solutions aiming at reducing the congestion in the network. As we know, congestion is quite a large issue, since due to the congested areas in the network, we have larger packet loss rate, we have unfair use of energy at nodes, and we have also delays. And this is something we have to deal with. So we want to improve the performance of LDV-based protocols without increasing significantly the overhead. This is the description of the problem. Basically, if you consider yellow nodes as transmitters, they're going to transmit over the receiving node, and we have this congested area. What we want to do is to force path to diverge basically. And we propose some solutions. The first one is pivot-based solutions. In LDV, the paths are selected according to hop count and connectivity, and interference is not taken into account. So this is basically the main issue. And what we do here, instead of going directly to the receiving node, sending data, we have the initial phase where we search for pivot nodes. Pivot nodes are selected according to set of criteria, which I don't have time to describe now, but I can give a reference to a paper. Basically what we do, once we find this pivot node, we transmit using the LDV to the pivot node data, and then from pivot node to the receiving node. The second solution was kind of cross-layer solution. At the network layer, we use information coming from the MAC layer, taking into account collisions at the MAC level. So in this way, we optimize the path we find toward the destination node. Our aim is, not as in many other work, to optimize the way LDV build paths, but to change the paths that are built, to force them to be different. And of course, before implementing this on the platform, the reasonable step was seeing how this behaves in simulations, whether if it really introduces some improvements. So yes, these are some results we obtained in simulations. And we see that the improvement with respect to default protocol exists. So the next step is, once we deployed this testbed, to implement it on FlexTop and see the results we obtain, and then compare everything, simulations, experiments. So what we can then go back to the first step, determining the offset between simulations and experiments. And now, the last part, I will just briefly go to the one application, Smart City application, that was
1 minute.
1 minute, okay. So municipalities, large, they have a huge issue with the public lighting system, because it's the main energy consumer. So what we can do, we can deploy a wireless sensor network to cope with this. And this is the architecture. Slides will be on disposal. I will just say that what we did, we deployed these nodes. The devices were measuring light coming from environment, and then according to the amount of light coming from the environment, from cars, shops, whatever, we dim the amount of light provided by the lamp. And this first, okay, here we can see how the architecture, the devices that we used. And this is the map of this little town, Casal Grande, which we deployed 24 nodes, 25 meters between each of them. Devices were measuring light. They were then sending data toward the coordinator. Coordinator was processing data, and then after processing, sending commands to specific nodes to dim or not to dim the amount of light. In this case, we use ZigBee many-to-one routing protocol. Okay, data was transmitted on 30 seconds. So this project has been done, it's finished, it's working, the testbed is there, 1 year already, everything is fine, but once we deployed UWIN, we wanted to see, okay, what happens if we can downscale it? Let's check how this thing works in FlexTop. Because if you don't have an opportunity to go out and deploy everything, as we heard, dealing with municipalities and bureaucracy is quite an issue. And we reproduced the scenario. Then we again had to match parameters, transmit power, and some other things to match as much as possible both experiments. The software was the same. We evaluated the number of hops which was necessary to reach the destination. We can see that it fits quite well. We also evaluated some other data, which I'm not presenting here due to the lack of time. We evaluated distances between topologies. Also, we evaluated packet loss rate was in both cases 0. And that's, I think, all I want to say. This is just to acknowledge people that I work with. And if somebody needs, because the main point was to describe testbeds that are on disposal to everybody who is interested, and there is just a certain procedure that has to be performed. This is the website of the new Centar project and the UWIN, and my email if there are some further questions. Thank you.